Hello learners, this is Education Online program. Our subject is chemistry and the topic is gas law. So this topic is for senior 3 and 4. So learners, we have known that the gas law depends on the kinetic theory of gases. We said that the gas are very small and relative to the distance between their molecules. And it means that because they are very small, they collide with each other, and here they expand and contract at constant temperature, and also we use pressure and volume for determining their presence. So we shall have the second law, which is known as the Charles law. Charles law, it follows the Ball's law, which is actually telling us that the volume and the pressure, they are inversely proportional to each other when we keep the temperature constant. So Charles law is going to be the opposite of the Ball's law, and here the Charles law is going to say that at constant pressure, when we keep the pressure constant, the volume of a fixed mass of any gas or any dry gas is directly proportional to the absolute temperature. Is directly proportional to the absolute temperature when we keep the pressure constant. So in Ball's law, we have the temperature is kept constant, but here in Charles law, the pressure is kept constant. So what changes is the temperature and the volume. So let's put this one down by saying that the second law of gas is known as the Charles law. Second law of gases. Second law. The second law of the gases is called Charles law. So here Charles law, it is actually telling us that the temperature and the volume, they are proportional to each other. If there is increase in temperature, there is increase in the volume. So if there is decrease in the temperature, there is also decrease in the volume. That is why it is stated that it is proportional to each other. So here we are going to say that there is absolute temperature. So absolute temperature is the temperature measured with respect to absolute zero on Kelvin scale. So absolute temperature is measured with respect to absolute zero on Kelvin scale. So if the absolute temperature is decreased at constant pressure, the volume consequently decreases. So here the temperature is known as the absolute temperature. So the temperature is known as the absolute temperature. So the temperature is known as absolute temperature, and here we measure this temperature by Kelvin. We measure this temperature by Kelvin, not by degrees centigrade. So at absolute temperature, we are going to measure the temperature, which is going to change with the volume. So we shall have it as if the absolute temperature decreases, as we have said before, that the pressure we kept it constant, and the temperature and the volume are the one that changes. So in this case, we say that the temperature, if there is change in the temperature, there is also change in the volume. So if you have increase in the volume, there is increase in the pressure. So the relationship can be represented as, first of all, we stated that Charles law states that at constant pressure, the volume of a fixed mass of a gas is directly proportional to its temperature. Here we represent it as absolute temperature. I've said before that this absolute temperature is represented in Kelvin on Kelvin scale. So this absolute temperature here we represent it as 0 at the Kelvin scale. So we said that this Charles law said that the constant pressure the volume of a fixed mass of a gas is directly proportional to its absolute temperature. So learners, we need to know that volume is directly proportional to absolute temperature at constant pressure. So we shall represent this one mathematically as the volume is directly proportional to the absolute temperature, or we can introduce the constant, which is K, and we say that V, which is the volume, will be equals to the constant, which is K, and here we can cross multiply and we say that the volume over the temperature will be equals to the constant, which is K. So in general, when the volume changes from volume 1 to volume 2 and temperature changes from temperature 1 to temperature 2, the equation becomes V1. So in general, let us say that in general, when the volume changes from volume 1 to volume 2, and the temperature also changes, and the temperature changes from temperature 1 to temperature 2. So this equation becomes like this. So at first we said that the volume is proportional to the temperature, or the absolute temperature. So we said that the volume will be equals to the constant, which is represented by K, and we multiply by the temperature. So we cross multiply and we say that volume over the temperature is equals to the constant. So here, if there is changes in the volume and the pressure and the temperature, then we shall say that the volume changes from volume 1 to volume 2, and the temperature changes from temperature 1 to temperature 2. So you need to remember the theory, the kinetic theory of gases, which state that the gas are very small, and relative to their distance, the distance between their molecules. So here, because there is a smaller distance between their molecules, this makes them to collide with each other and with the container that they are kept in. So if they collide, it means there is going to be change in the temperature, and there is going to be change in the pressure. So we shall say that this we represent it by temperature 1 and temperature 2, also volume 1 and volume 2 here, because we kept the pressure constant, and this is what Charles said about. So we are going to have that, therefore we shall have volume 1 over temperature 1 will be equals to K. Also we can say volume 2 over temperature 2 will be equals to K. So when we combine this together, we shall have temperature volume 1 over temperature 1 is equals to volume 2 over temperature 2 for a fixed mass of a dry gas. So for a fixed mass of a dry gas, we shall have volume 1 over temperature 1 is equals to volume 2 over the temperature 2. Remember that this temperature is known as absolute temperature, and this 0 is read in Kelvin scale. So we need to remember that this volume 1, as we have known in Bowles' law, volume 1 here is representing original volume. And volume 2 is the final volume. So temperature 1 here is the original temperature, and temperature 2, the same as we have for the volume, is the final temperature. So we need to remember the changes in the temperature and the volume. So we said volume 1, it means this is original volume. Volume 2 is the final volume. Temperature 1 is the original temperature, and temperature 2 is the final temperature. Remember that this is read in Kelvin, not in centigrade. So it means here the unit for this temperature will be K. So not C as we have for the Celsius. So let us have an example here to show how we calculate the temperature and the volume for this matter. So first of all, at any temperature, the temperature at which the volume of any gas is theoretically 0 is called absolute 0, and it forms a useful bottom limit to a new scale of temperature. So the absolute scale, whose unit of temperature is Kelvin, we are going to have that the temperature T, if we are given the temperature in centigrade, so we shall have, this will be equals to, we need to change it into Kelvin by adding 273 into the temperature given. So we shall have this as Kelvin. So here minus 273 centigrade would be 0. Or we say that Kelvin can have 0 Kelvin. So here I'm giving you this one as we are going to have some temperatures in centigrade. So we need to change them into Kelvin. So if you have a temperature in centigrade, you need to add this value, which is 273. So at minus 273 degrees centigrade, this temperature would be 0, or we represent it as 0 with the capital K at the end, which is representing Kelvin scale. So we shall have now to remember that at 0 degrees centigrade, this would be 0 plus 273. So this will be equals to 273 Kelvin. So at 100 degrees centigrade, we shall have, this will be equals to 100 plus 273, which is equals to 373 Kelvin. So here we have changed from Celsius to Kelvin, because we are representing this temperature as absolute temperature. So learners, we shall have an example to represent this, and we say that example 1. So here example 1 is going to say it like this. Example 1, we are going to say that a sample of a gas. So for this matter, we are going to have a sample of a gas. A sample of a gas occupies 60 centimeter cube. So here we say this is the volume. So the unit for volume usually is centimeter cube or decimeter cube, or in other matters we can have them in liters. So centimeter cube at 35 degrees centigrade. So at what temperature would it occupy 96 centimeter cube if the pressure remains constant. If the pressure remains constant. So what will be the new temperature if we kept the pressure constant? So with this, if you see that there is constant pressure, you need to remember that this is Charles' law. If you have constant temperature, then you have the Bowles' law. So we need to differentiate between the Bowles' law and the Charles' law. For this matter, we have to find out the temperature, and also we need to see that if there is volume there, then we need to remember that this is representing Charles' law. So for this matter, you are asked to get the new temperature when the volume occupied is 96 centimeter cube. So we have to note them down, and we say that the volume 1 over the temperature 1 will be equals to the volume 2 over the temperature 2. So we put the formula down. Solution. So our usual formula is volume 1 over temperature 1 is equals to volume 2 over temperature 2. So given is V1. So V1 here, which is volume 1, is 60 centimeter cube. So we have 60 centimeter cube. So temperature 1 is what? Temperature 1 is 35 degrees centigrade. Remember that this is in centigrade. We need to change it into Kelvin by adding 273 to change it into Kelvin. So we shall have temperature is equals to 35 degrees centigrade plus 273. So we change this into Kelvin. So we shall have, when you add 273 to 35, we shall have 2308. So 308 will be the new temperature, which is now in Kelvin scale. So we change 35 into Kelvin. So because it is in Celsius, so also we need to remember that the volume 2 is given, which is 96 centimeter cube. So this is 96 centimeter cube. So 96 centimeter cube is the final volume. The original volume is 60 centimeter cube, and the temperature here, which is represented by temperature 1, is the original temperature. What is required is the final temperature. So here T2 is unknown. So we have now to put this into, we have to put it into the into this formula, and say that temperature 2 will be equals to, by alternating this, we are going to have temperature 1 multiplied by volume 2 over volume 1. So here we have seen that all these are given with the exception of temperature 2. So we shall have temperature 1 is 308, then we multiply by volume 2, which is 96, then we divide by volume 1, which is given as 60. So if we calculate this out, will give us the final temperature. So here the final temperature is 492.8 Kelvin. So here is the temperature 2. So learners, we have seen that the difference between Charles' law and Ball's law is only in the calculation here. It's representing that the temperature and the volume, they are proportional to each other. If there is increase in the temperature, there is also increase in the volume. So if there is decrease in the temperature, there is also decrease in the volume. So we have seen that the temperature 2 was not given, but temperature 1 was 308 and volume 1 is 60. So when it increases to 96, also the temperature increases. So learners, we shall have another example to verify this Charles' law. So this example 2, it says like this: the volume fixed or fixed mass of a gas was found to be 204 centimeter cube at 288 Kelvin. So what would be the temperature? What would be the temperature in Kelvin? What would be the temperature in Kelvin for the same gas? If its volume increased to 280 centimeter cube. So learners, we have seen this example, and it shows us that the volume of fixed mass of a gas was found to be 224 centimeter cube at this temperature, which is, we represent it as temperature 1. So we have to go back to our formula, which says that temperature volume 1 volume 1 over temperature 1 is equals to volume 2 over temperature 2. So volume is given as volume 1 is equals to 240 centimeter cube. So here volume 2, what would be the temperature on Kelvin for the same gas if its volume? So in this case we have volume 2 is equals to 280 centimeter cube. So temperature 1 is given here, which is 288. So in this case, this one is already converted to Kelvin. So the temperature remains as it is, 288. So temperature 2 is the one which is required. So we shall have to see that the temperature, we are going to multiply it with the volume 1. So we shall have volume 1 and temperature, volume 2 and temperature 2 will be up, and we shall have temperature. So we shall have temperature 2 is equals to volume 2 temperature 1 divided by volume 1. So we have to have 280, which is volume 2, and temperature 1 is 288. Then we divide by 224. So 224 is the original volume. So when we calculate this out, will give us temperature 2, which is the final temperature. And for this matter, it is 360 Kelvin. So 360 Kelvin is the new temperature or the final temperature when the volume increases. So when the volume increases, we have seen that here the volume, when it is 224, the temperature is 280. The temperature is 288. So when the volume is 2, it means it has increased from 224 to 280. So when there is increase in this volume, the temperature also has to increase. So learners, we have seen that here the temperature is 228 or 228, and the new temperature or the final temperature is 360. So it has changed from 288 to 360. So with these learners, we have seen that Charles' law is actually having that the temperature and the volume, they are proportional or directly proportional to each other. So we have seen that here the temperature and the volume, they are proportional to each other, but what is kept constant is the pressure. So at constant pressure, we can have the volume is directly proportional to the temperature, which is, in this case, we say that it's an absolute temperature, and we have the unit for this absolute temperature as in Kelvin scale. So with these two examples, you can also go ahead and calculate some other problems in Charles' law. So we have come to the end of this lesson. So thank you very much for listening.